The PowerPoint presentation on the variable valve timing technology, Unit 2 and Session 2 in Advanced Automotive System. So variable valve timing stands for VVT. Table of content. Introduction, inlet valve timing, exhaust valve timing, the basic mechanism, operations, cam changing variable valve timing in Honda VTEC, advantages and disadvantages, applications, conclusion, multiple choice question, and obviously the references. First, introduction of variable valve timing. Of course, the variable valve timing, the VVT, started at 1990s. In internal combustion engine, variable valve timing VVT is the process of altering the timing of valve lift event and is often used to improve performance, fuel economy, or the emission level. It is increasingly being used in combustion with variable valve lift systems. This technology is used valve timing of the engine as it directly relates to the amount of charges. Amount of charges means fresh charge. Fresh charge means fuel and air getting into the engine cylinder. This technology is directly related to the fuel economy, and of course, so this is the major advantages of this system. These technologies also work upon the emissions point of view. It is lesser emission. Once the complete combustion it happens in the combustion chamber, obviously less fuel consumed and less emission level. 100% combustion, the air and fuel mixture 100% completely burnt that inside the combustion chamber. Obviously that less emission going out, and of course this technology is more fuel efficient, and it become popular on gasoline passenger cars. Valve timing is the regulations of the points in the combustion cycle. The cam setting determines the timing of the valve. The inlet valve is set to open before top dead center, and the exhaust stroke closes after bottom dead center. Inlet valve timing. The intake valve should opens theoretically. Theoretically means as per the valve timing diagram at top dead centers. Most engines utilizes an intake valve opening which is timed to occur a few degree before to the arrival of the piston at the top dead center on the exhaust stroke. The exhaust valve timing. As per the valve timing diagram, the exhaust valve is set to open before bottom dead center and towards the end of the power stroke and closes after TDC, I mean top dead center. The reason the exhaust valve is open before bottom dead center to prevent the exhaust gases from forming high pressure cushion. Basic mechanism. With VVT, a sensor is used to detect the engine speed, like crankshaft position sensor. It works with that at what stage the piston moves in each and every cylinder. And electronic systems then uses this information. Electronic system means it's a ECU, electronic controlling unit, that what we used in the automobile industry to adjust the valve opening and closing, the timing accordingly, the valve timing diagram. This avoids the problems associated with static valve timing. Also allows for maximum torque at all engine speeds. The operations of the VVT. In the operations of the VVT, the end of the camshaft incorporates a gear threads. The threaded is coupled by a cap, that is in that the closed manner, which can move towards and away from the camshaft. The gear thread is not parallel to the axis of camshaft, and face angle will shift forward if the cap is pushed towards the camshaft. In VVT technology is improves a peak power, just like an engine with camshafts, and increases top end power. However, Such power gain at load speed torque gain too little tractability. That means, you remember, the cam of normal engine usually serves across 0 to 6000 rpm, while the slow cams of the VTEC engines still needs to serve across 0 to 4500 rpm. It's pulling the cap away from the camshaft, result in shifting the face angle is backward. The hydraulic pressure, it determines push or pull, thus shift the face angle forward movement. Continuous variations in the timing, it is easily implemented by positioning the cap at a suitable distance according to the engine speed. The cam changing VVT, that means Honda VTEC technology. In Honda motors pioneered in road cars used VVT in late 1980s. In 1980s, it is already used this technology in Honda people. It is famous for that the VTEC system, valve timing electronic control system. In the valve timing electronic control mechanism, obviously two sets of the cams, the two sets of cams having different shapes to enable in different timings and lift for a frequent intervals. One set operates during the normal speed, say below 1500 rpm, and another one it operates and above 4000 rpm. This system thus improves peak power because for a frequent periodic intervals, the two sets of cams it's operate, and it will helps to the more fresh charge enter into the combustion chamber. So definitely we will get that 100% combustion and better swirling action. That ultimate result is less emission and less consumed fuel. The Honda has introduced this technology late 1980s, and it improves two-stage VTEC system now into 3-stage. First, in older version there is a 2-stage system we are using, but nowadays the Honda people were introduced in 3-stage in some models. In the cam changing system remains to be most powerful of variable valve technology. In Honda, VTEC system, there is a 3 stages: stage 1, stage 2 and stage 3 process. The Honda latest 3-stage VTEC system is in Honda Civic SOHC system. SOHC means single overhead camshaft engine in Japan. The mechanism has 3 cams with different timings and lift profiles. Note that their dimensions are also different in 3 cams. The middle cam, fast timing and high lift. The right hand side cam is slow timing, medium lift, and medium size cam. So here that one point that we consider all the 3 cams in different in sizes. The third cam in medium size, the left hand side cam, that is slow timing and low lift. In PowerPoint shows the stage 1 at low speed. Stage 1 at low speed. In the low speed, rocker arm, the figure shows the rocker arm, the inlet valve and cam to operate the VTEC system. The 3 pieces of rocker arm move independently. Therefore, the left rocker arm, which actuates the left inlet valve, it is driven by the low lift left cam as shown in figure. The right rocker arm, which actuates the right inlet valve, it is driven by the medium lift right cam. In stage 1, the cam operates at the low speed. Stage 2 at medium speed, the figure shows that sets up that rocker arm and positions and the rocker arm and the cam position and inlet valve position. The hydraulic pressure locks the left and right rocker arms together, that both left and right rocker arms is locked, leaving the middle rocker arm and cam to run their own. Since the right cam is larger than the left cam as shown in figure, both are connected. The rocker arm are actually driven by the right side cam. As a result, both inlet valves obtain slow timing and medium lift. We will go for that the next slide, stage 3 at higher speed, and as shown in figure, it consists of that rocker arm, cam and the inlet valve, and the directions of valves it moves, so that it will shows in figure. So here in the high speed, in stage 3, the hydraulic pressure locks all 3 rocker arms together. Since the middle cam is the largest one as compared to that both the rocker arm, both inlet valves are actually driven by that fast cam. Therefore, fast timing and high lift are obtained in both the valves. The advantages of VVT. VVT improves torque delivery across the whole revolution or the speed range. Definitely it improves the torque delivery, because the VVT it consists of that the different size cams are used to open the valves in frequent intervals. So at that time, obviously, that more fresh charge enter into the combustion chamber and 100% combustion and less emission. So once 100% combustion, that what will get, so definitely improves the power and the torque delivery, and obviously less fuel consumed. The continuous VVT improves torque delivery across the whole revolutionary range. The variable lift and duration. Lift high, the revolution power. The powerful at top end. So this is the ultimate advantages. The VVT, this technology, it gives so ultimate top end power. The disadvantages of VVT. Lack of variable lift and variable valve opening durations. So because that even single shaft it consists of that more cams, I think that lack of sequences. So this is the major disadvantages of this system. Thus it produces less top end power if it is lack of variable lift and variable valve opening during the operations. Obviously it gives that less top end power, and whole system it's more expensive, and this technology of course it's more complex. This technology are used in automobile industries. Most of the car makers such as Audi V8, BMW, Ferrari, Fiat, Ford Falcon, Jaguar and Lamborghini, Mercedes, Nissan and Nissan V6, V8, Porsche, Toyota, Volvo and the Volkswagen. So most of the car makers are used this latest technology. There is no doubt about it. And finally, what I concluded, the conclusion. I conclude VVT devices has been used in IC engines. Definitely 100% it improves the engine performance over wide range of speeds by utilizing the variable valve timing and lift, and of course it can also be used to give fully variable stroke in another reciprocating devices. This can be used a wide range of applications that what I told the previous slides in application. The most of the car manufacturers, it fully variable displacement, the pumping devices is required. The overall, the VVT technology, it gives complete combustion, less consumed fuel, and we will get that more power, I mean that 100% power with less emission content. Multiple choice questions. In variable geometry intake manifold, the rotary valve closed in dash RPM, revolution per minute. Option A, high RPM. Option B, intermediate RPM. Option C, low RPM. Option D, very high RPM. The answer is option C, low RPM, revolution per minute. Next question. In variable valve timing used on dash and dash engine design. Option A, VVT and OHV. OHV stands for overhead valve mechanism. VVT, variable valve timing. Option B, OHC. OHC stands for overhead cam system and overhead valve system. That means OHC and OHV. Option C, VIM and VIS. Variable intake manifold, variable intake system. Option D, VVT and VIT. Variable valve timing and variable intake technology. The answer is option B, OHC and OHV. OHC stands for overhead camshaft arrangement and overhead valve mechanism. Next question. The VTEC stands for a variable technology. Option B, valve timing electronic control. Option C, valve timing engine control. Option D, variable valve timing and electronic lift control. Answer is option D, variable valve timing electronic lift control. So that is stands for VTEC, variable valve timing and electronic lift CFR control. Next question. EGR. EGR stands for exhaust gas recirculation system. EGR, exhaust gas recirculation, is a commonly adapted technique to reduced dash. Option A, emission. Option B, fuel efficiency. Option C, intake air. Option D, engine performance. Answer is option A, emission. Next question. The electronic control unit ECU, which calculates dash in VVT technology. Option A, exhaust valve opening. Option B, cam operations. Option C, piston movement in TDC and BDC. Option D, intake valve timing. Finally, answer is option D, intake valve timing. Next question. Toyota originally introduced dash technology. Option A, VVT-I, that means variable valve timing intelligence system. Option B, VVT, variable valve technology. Option C, VVI, variable intelligent valve. Option D, VVL, variable valve lift. Answer is option A, VVT-I, variable valve timing intelligence. The Toyota people were introduced the VVT-I technology, variable valve timing intelligence technology. Next question. Valves are defined as devices to control or regulate the commencement and dash air. Option A, flow. Option B, direction. Option C, atmosphere. Option D, control of air. Answer is option B, direction. Direction of air. Next question. The quick exhaust valve is used to exhaust the cylinder air quickly to option A, atmosphere. Option B, air intake. Option C, recirculation. Option D, intake manifold. The answer is option A, atmosphere. Next, state true or false. Pressure losses in manifold type valve is more than in line type valves. So it is true or false. The statement whether it is true or false. Of course, the answer is the statement is true. So because that pressure losses in manifold type valve is more than in inline type valves. Of course, the statement is true. Next statement, true. State true or false. Suspended disc type valve has very long actuation moment. The disc type valve has very long actuation moment. Of course, answer is false. The statement is false statement. The disc type valve is quickly actuation moment. So that's why this statement is false statement. Next is the references. that what references that we taken to prepare this slide, and refers some books, a system approaches automotive technology, of course, electronics, engine controls with sensors, advanced vehicle technology, and automotive technology, and automobile technology by basic things, and some websites links, and go through that and to prepare the slides. Thank you for patience hearing. Thank you very much.